Hi, sixth grader. Today we're going to talk through surface area. Grab your notebook, get your page ready, and press play when you're ready to continue. Surface area is the sum of the area of all faces of a three-dimensional figure. So we're looking at the area of all the sides of the 3D figure and adding those together. Surface area is still two-dimensional because it is only the sum of all of the areas, so our units are written as units squared or square units, just like areas units are. Press pause if you need more time. Let's try finding surface area of a rectangular prism. Here's our rectangular prism. If you draw two rectangles and stack them near each other and then connect same point to same point, you will have this similar figure. Don't forget to add your units. We can find, there's two ways to find surface area. So really what we're doing is we're finding the area of each face and then getting a total, so adding them together. So we could do a little coloring visual here to help us see that. If I were to color this side, this rectangle, I notice that it's made up of a 21 and a 7. Those are the two units that would make up its base and height. So to find that area, we could take 21 times 7. And then I notice that I have the same rectangle on the other side of the prism. So once we get the total, 7 times 21 is 147 for this side's area. I'm just going to double that since I know I have the exact same figure on the other side. So I'll have two figures with that same area of 147, which gives us a total of 294. Next, I'm going to look at the front face. This front face is made up of the dimensions 34 and 7. So to get that area, I'm going to multiply those together to get 238. I know that on the other side of the figure, I have the same exact, I don't have it shaded in there, but on the other side of the figure, I have a rectangle with the same exact dimensions. So I can double that to get a total of 476 for both of those rectangles together. We have the sides, we have the front and back. The last piece we're missing is the top and bottom. If I shade that in, I see that the dimensions for that top rectangle are 34 and 21. If I multiply those together to get 714, I know I have the exact same rectangle on the bottom, so I can double that to get a total of 1,428 for both of those rectangles together. Now that I have all 6 sides in isolation, I can add those together to get the entire area of this figure's surface, or surface area. When I add all of those together, I get 2,198 centimeters squared. On a rectangular prism, you'll always have 3 identical sets of rectangles, so it really only looks like 3 problems. But don't forget, you have 6 sides because you doubled each of those to represent 2 different sides that had the same area. That's kind of the longer way, and it's for those people that really like that visual of what's going on. And it's really nice to kind of color code and see all those sides. But we can also use a formula. So let's look at the same exact problem using a formula. The formula for surface area is capital P, which means perimeter of the base, times height, plus 2 times capital B, which means area of the base. So when a letter is capitalized, it's referencing the base. So I'm going to just write this in, perimeter of base and capital B means area of base. So if you have that formula written down, you want to add these notes here. And H just means height of the figure. Struggling with letters here. There we go. And this is just height of the figure. So let's look at what we mean by that. Oh, there it all is. P equals perimeter of base, H equals height of figure, capital B means area of base. So when we have a capital letter, it's talking about the base. You can pick which set of sides for a rectangular prism that you want to represent the base. Let's say I started with this bottom rectangle as the base. So if I need the perimeter of the base, I'm going to add up the four sides. That's how I find perimeter. 21 plus 21 plus 34 plus 34, that's 110. The height of the figure is the distance between the two bases, which is highlighted here as 7. And the area of the base is multiplying your two dimensions, your base and your height, that make up your base. So that's 34 times 21 to get the area of that figure, 714. Now we plug those into the formula. I take 110, plug it in for the perimeter of the base, times the height, which was 7, plus 2 is part of the formula, times the base area of the base, which was 714. When I plug those into my calculator, I get 2,198 centimeters squared, just like we did on the last example. I recommend, it's really nice to use this formula. You can use the other method. I'll leave that up to you on what makes the most sense for you. Let's go ahead and try one on your own. Press pause while you try this. Press play when you're ready to see the answer. I'm going to use the formula, which, just a reminder, it was perimeter of the base times height plus 2 times area of the base. Pause now to try it. Press play when you're ready to hear me go through the answer. All right, so perimeter of the base. Depending on what you picked as the base, and no matter what side you picked, you should get the right answer. Let's say I use this bottom rectangle. So I had 6 plus 3 plus 6 plus 3. So I'm getting 18 as the perimeter. Height of the figure is the distance between the two bases. So this line is the distance between the two bases, which is 10. Okay, plus 2 times area of the base. So my base was made up of 6 and 3 down below. So if I multiply 6 times 3 to get the area, I would get 18. Now let's plug that in. 8 times 10 is 180, plus 2 times 18, which is 36. I'm getting 216 centimeters squared. We have one other type of prism that we want to work through today with surface area. We have a triangular prism. To make this prism in your notebook, make a right triangle, go up and back, and create the same right triangle. They don't need to overlap, they can if you want. And then connect same corner to same corner. Top to top, bottom left to bottom left, bottom right to bottom right. And don't forget to add in your dimensions. To find area of this prism, we're going to find the area of each face. So let's go ahead and start with the bases, which are our triangles, and we have two that have the exact same dimensions. When finding area of a triangle, we need to take base times height and divide by 2. That's why we took 15 times 8 and divide it by 2, which gives us 60. That's because we're working with triangles. Then I know I have the exact same triangle on the other side of my prism. So now I'm going to go ahead and double that 60 to get both of the triangles' areas together, which is 120. Let's move on to the rectangles. The rectangle, if I think of this as a skateboard ramp, so that rectangle that kind of holds up the ramp at the back is made up of two dimensions. I see 8 along the side, and then at the bottom of the figure, I know that that's parallel and congruent to this 9 over here. So that's going to be made up of an 8 and a 9. So I multiply those together to get 72. It's a rectangle, so I don't need to divide by 2. This rectangle does not have a matching one on the other side, so let's move on to a new rectangle. Kind of the bottom, if this were to sit on cement, that rectangle at the bottom is made up of 15 and 9. So I multiply those to get an area of 135. And it kind of looks like we're all filled in, but we actually still have this top pane where the skateboard would actually go, and that has dimensions of 17 and 9. So when I multiply those together, I get 153. A triangular prism has 5 sides, so this is 2 triangles plus 3 rectangles. That's all 5 sides. To get the area or surface area, we now add up all of those areas. And that gives us 480 millimeters squared. Let's look at the formula for this type of problem. Same exact prism, same exact formula. It's just going to look different with triangles instead of rectangles. So we're going to start by finding perimeter of the base, timesing that by the height, adding that to 2 times the area of the base. You do not have the luxury of picking your base on this prism. You need to use the triangles for your bases because those are the only 2 polygons that are parallel and congruent here. Let's start by finding perimeter of that triangle. I have 15, 17, and 8 as my 3 side lengths. So to find perimeter, I add those together to get 40. The height, it's kind of tricky here. It's the distance between the 2 triangles. So it's not how tall it's standing, it's the distance there. So our height is actually 9. And then area of the base, we're going to take base times height and divide it by 2. So 15 times 8 divided by 2 is 60. We take those and plug them into our formula. 40 times 9, perimeter of the base times height of the figure, plus 2 times area of the base, which was 60. When I plug those into my calculator, I get 480 millimeters squared. Let's try one of those on your own. I'm going to use the formula. Press play when you're ready to hear the answer. All right, you guys, let's go through that answer. My base here are my triangles. I must use my triangles because those are my only 2 figures that are parallel and congruent. To find the perimeter, the side lengths here are 10. So I need to take 10 plus 10 plus 12. That would give me 32 times the height. The height is the distance between the triangles, which is 15, plus 2 times the area of the base. The area of the base would be, let me switch colors here. Let's see, base times height divided by 2 because it's a triangle, so 12 times 8 divided by 2 is 48. So I'm going to plug that in for the area of the base. Now I can solve. 32 times 15, I'm just going to break this up a little bit because I'm on a phone calculator. And then 2 times 48 is 96. I'm going to add those together. This will give me my surface area, 576 meters squared. And that's using the formula method. Okay, that's all I have for you guys today with surface area. Check in with your teacher if you have any additional questions. Next, let's find surface area of cylinders. For surface area of cylinders, we take 2 times pi times the radius times the height plus 2 times pi times the radius squared. Let's look at our first example. Remember that the diameter is the whole way across the circle, and the radius, which is what we need, is halfway across the circle. So if the diameter here is 6, our radius is half of that, which is 3. So let's go ahead and plug those into our formula. We're going to take 2 times pi times the radius, 3, times the height of the cylinder, which is the distance between the circles, 13, plus 2 times pi times the radius, which was 3, squared. We're basically taking the area of the circles and adding that to the area of the piece that connects the circles. Use a calculator with the pi function to help you get this answer. 2 times pi times 3 times 13 plus 2 times pi times 3 squared. I'm getting a long decimal, which is very common when you're working with pi, so we're just going to round to the nearest tenth, 301.6 centimeters squared, since this is surface area. You try this example. Find surface area, press play when you're ready to see the answer. All right, you guys, so you want to plug in your radius, which they gave you, 4, and your height, which is the distance between your circles, 8. So it's going to be 2 times pi times 4 times 8 plus 2 times pi times 4 squared. Add that 2 pi at the beginning. Okay, let's plug that in and see our answer. I'm getting, wait, 301.6? Do we get the same thing? 301.6? I'm going to double check that. Okay, 2 times pi times 4 times 8 plus 2 times pi times 4 squared. I got the same thing, 301.6 centimeters squared. All right, you guys, check in with your teacher if you have any questions about surface area.